Okay, perfect. So yeah, let's start. First of all, for now, let me, of course, introduce myself as a host, because I already started talking, but then let's actually introduce all of us over there. Yeah, so as you might already know, I'm Paula Januszkiewicz, and what I'm doing for a living, simply, it's cybersecurity for the past 20 years. This is really funny. And also, funny part is that, I'm engaged in penetration testing. I'm also engaged in incident response forensics, and my company, CQURE, that I've established by myself 15 years ago, it's celebrating 15 years, and we're going to be having a little birthday out there on the 2nd of November. So that's basically the setup. And we are here all together with all the amazing gigs that I have a chance as well to work with, and they have a chance to work with everybody else from the team and so on. So that's the case, and we are here, of course, to share with you quite a lot of interesting tips on simply how to secure your Active Directory, how to defend it. And so that's this 6 things on defending Active Directory, hidden gems, and application whitelisting master tips. So that's the setup. So from now on, let me, of course, stop sharing the screen, because it's time for a little bit of an introduction. So we've got Sami. So Sami, if you don't mind doing introductions, that would be fantastic.
Hi, everyone. Sami Laiho, Finland, Microsoft MVP since 2011, and been training security and Windows for my whole life, and worked with Paula almost as long as CQURE has existed. So happy to be back.
That's fantastic. Thank you so much. That's great. So also content and order-wise, how we're going to be presenting. We've got Michelle Grafnetter. Hello. How is it going?
Hi. Hello, everybody.
Perfect. And if you don't mind just telling a couple of words about yourself, that would be fantastic.
Yeah, so hi, I'm Michael. Some of you know me as the author of DS Internals or Directory Services Internals PowerShell module. I do Active Directory security research, and I'm thrilled to show you a couple of things I've been working with for the past couple of weeks.
Absolutely. Thank you so much. And who doesn't know you, like the famous DS Internals module is used by everybody. So I think we can say that. So I'm also looking forward, of course, to your part. And we've got as well Peter. Hi, Peter. How is it going?
Hi, everyone. So my name is Peter. I'm located in Warsaw, Poland. So cooperate with Paula for many years, and it's a huge pleasure to be here. My special, let's say, I'm specialized in few things, like definitely it's a blue team story. So how to protect Active Directory and other workloads in the cloud, in the on-premise. And I'm let's say, fascinated also with the red team party. So I believe I can share some details today.
That's awesome. And there's so much that you do in terms of monitoring. So you do all the magics that the blue team does. And that would be lovely also to see that in terms of these 6 things that we are discussing today. So there's also Mike with us, Mike Jankowski-Lorek, and he is on the chat. So basically, he's going to be supporting us while you guys are going to have many questions. And we really hope you will, because this is why we are here for you. So that's the setup. Just a couple of words, of course. We do penetration testing, we do trainings, we do different services, right tools. So you basically know it all. And we'll be happy, of course, to share with you more information about that. But today we are focusing on knowledge, and there's a couple of important things to keep this smooth and without any hesitation. First of all, if you have problems with viewing this webinar, try refreshing the page first, or try, of course, another browser. I know that sounds like a very simple tip, but you might be actually using something unusual. So we don't know that. So in general, refreshing things might help. Also, if you wish, of course, to get more information, then you can always write us at info@CQUREacademy.com. This is something that we are monitoring as well right now. So please let us know. And if, of course, you watch this webinar directly from YouTube, and it could happen, the stream crashes like it usually does in a very unpredicted moments, then please follow the chat window here and the comment section for the new link, and we're going to be immediately posting this for the recovery. It actually happened to us before, and we had a pretty smooth recovery. So, well, first, hopefully we will not need to do that today, but if it happens, then that's manageable. Yeah, so eventually we're going to be back. So what can you expect today? Well, lots of things. It's going to be an 1.5-hour session today, so I hope your brain is super fresh, because here is what we're gonna come with today. So prepare your questions, because we will be finishing with the live Q&A as well, where, as many of you guys know, we are like answering almost all of the questions, and sometimes because of that we run a little bit out of time, and my team is always trying to stop us talking, so they never succeed. So here we go. But there's a couple of things, of course, that you see: technical demos, tips on how you can learn with us. There's also a live challenge. It's important, with a cool prize. And that is also very important, because we got a challenge for you, and we put it on at the very beginning of our webinar. So please get engaged with it, because there is actually a cool prize at the very end. As always, there's always some kind of a well, little competition on our webinar. So looking forward to that. Yep. So let's of course discuss it. First of all, we've got the 6 things on defending Active Directory, hidden gems, and application whitelisting mastership. So if you guys ready, because we are over there, let's start. So what are these top 6 things on defending Active Directory? I would say that the first thing that we definitely should pay attention to, and let's start, it's going to be the human factor. And I would love to show you a kill chain attack that's going to be related with how, of course, regular user, not even running Windows, could potentially do some damage in the infrastructure. And we're going to start with simple things to end up with misconfiguration, and eventually to be able to leverage different permissions that we've got set up on the certain objects in the Active Directory, for example, on the computer accounts. And then eventually our job is going to be to see how we are able to perform any other malicious actions based on that. And then later, you're going to learn, of course, how to secure the server itself, what are the typical misconfigurations, and what are the not typical misconfigurations as well, and what can we do about it in terms of Active Directory. And at the end, Peter, of course, is going to explain how you are able to monitor it all. So how to make it all like in a circle. Now, the goal of that webinar, I have to say it before we start, is we could be talking about it for the next 10 days at least, but the goal of this webinar is to show you the spheres that require looking into, that require improvement, that require investing your time in. So that is basically what we will be covering today, with a little bit of demonstrations, with a little bit of slides. So the first part, it's the human factor, and that's simply the password spray. Yeah, so let's get into it. So what I've got over there, it's simply the console with Kali. Yeah, so this is just a user that doesn't really have any kind of like connection to the internet and so on. And our job is going to be to at that moment play a little bit, of course, with things that we see around ourselves within the domain. So that's also very interesting, because our goal is going to be here to, well, simply perform the password spray. So let's just do a cat user 60, and we did some OSINT phase where we learned what kind of users are potentially working within this company. So we're going to be using the users. So we're going to check out how many records we've got. So we've got 27 records. And then the next part, we're going to be, of course, leveraging over there the common password that we can pick over here to hit these users with, counting that some of these users are going to actually have this password. And for every single project, guys, we are dealing with this. So here we're going to be using crackmap exec, where we are specifying the IP address of the domain controller with the users list, and we're going to be hitting them with the password September 23. Why not? So eventually, like how do we know what's the domain controller? Well, we could be doing the network sniffing, and then we could see by the network communication pretty much which one is actually domain controller. And there are many ways of doing that. That could be the basic way of doing it. But eventually, this is the 10.1.1.1. And if, of course, we are leveraging somehow somewhere in this infrastructure DNS, then it's a very easy thing to check as well what is actually the DNS about. So once we run it, we are learning over there that we've got Jeremy Brooks, And Jeremy Brooks, that's actually the password, which is September 23, which means we're going to be actually, logging on with the Jeremy Brooks account. We could also set up a Windows account that's going to be added by the Jeremy Brooks to the domain. And as we know, the default setup is that the regular user can actually do that, can actually add that workstation to the domain. And we are actually quite often using it within the pen test. So I already did that, and eventually we've got a couple of things that we can perform, and we've got over there a machine that is actually already added with that Jeremy Brooks to the domain. Yeah, so that's basically the machine that also our team prepared. So we get a Jeremy Brooks, and then you can see that there is an IP address. So we get a 10.1.100, and from the Jeremy Brooks computer, we will be attacking a domain. So that's also quite nice. So let's just start PowerShell, whatever. We can start it with the basic option. And if you feel that you would like to deliver the same type of an attack, but on Windows, what you're gonna do, you will actually do the first scanning of the accounts by using the module that we're going to be here importing. Yeah, so we got a tools, and then the next stage over there is to, of course, perform the same type of activity. So let's just do import module, and then we're going to be here importing the module, which is the domain password spray PS1. And that's it. So of course, let's launch it. At the end, we could be using also the password list or the given password, like September 23 that we use. It doesn't really matter. So let's do invoke. And then we will be doing the domain password spray. And then we will be specifying here parameters. And one of them, of course, it's going to be the password that we got. And the password will be September 23. Yeah, so let's type that in. Now this is a little better because while we are already domain user, then we are not in the need of performing the OSINT. Yeah, so regular user, of course, can do that operation as well, and then check what kind of account is going to be affected. So it's easy. Now the power here is in monitoring as well, so that you know, and there are some errors, we can ignore that. But at the end, we see that not only Jeremy Brooks has a password September 23, but there's also J Bond. Yeah, and J Bond, well, may not have been on the previous list that we had in the Kali while we were performing the OSINT. Yeah, so we may not even know that that kind of user exists. And so that's basically the setup. Now, once we got that, the next stage, of course, it's going to be to perform curb roasting. And curb roasting is while we are, of course, on the level of the domain. So coming back to the second part over here, we've got a situation where we got a password spray that is actually complete. We're going to be performing the curb roasting in order to be able to, first of all, list the available service principal names, so the configurations of the particular accounts. So let's just move in over there, and that's one thing. And we're going to be actually doing, you can do it in a couple of ways. You can, for example, leverage for that even Mimikatz, but we're going to be actually using for that in packet get user SPNs, raccoons PL. You see Jeremy Brooks, September, and so on. We specify the IP address of the domain controller, and then we've got output file curb rows, where we're going to be storing information that we're going to be cracking later. Yeah, so that's a bit of a kill chain. So we came from nobody, and then we've got already possibility to scan the domain for the SPNs, and then eventually we are hoping that there's going to be some accounts, and we got 3, that's great, that have actually for this simple passwords that we will be able to, of course, crack later. So from that curb rows 1, we're going to be extracting information and we're going to be cracking it. For example, we could be using John for that or many other tools, but John is actually pretty good, and it's going to take some time for that attack, of course, to be delivered. So we are hitting here, well, we could be checking each of these accounts, but we are hitting over there for the SVC8 immigration, yeah, and John, format, Kirby, Kerberos 5, TGS, wordless. We're going to be using RockU on the Kerberos 1. Yeah, why not? RockU is like classic. Of course, we could be using better dictionaries, but using the default so that you guys can repeat, yeah, then RockU is actually very, very convenient here. Okay, and now, once we got that, John's going to take some time And this will be the time where, of course, what matters is our computing power. So the faster you want to have that done, the better CPU will need to have, and so on. So this is simply the cracking activity that we got. Now, for that, there's a couple of things that we might use as an opportunity. Yeah? So curb roasting in general, we need to know that it actually takes advantage of how service accounts leverage in general curb roast authentication with the service principal names. And in general, curb roasting itself allows us to crack passwords for accounts that are in this case logging into Active Directory domain as an authenticated users, and we are able here to request service tickets, so the TGS, for service accounts for specifying their service principal names value. And Active Directory will return, and that's what's in this file, the encrypted information. So eventually encrypted password, which is actually encrypted with the NTLM hash of the account that is actually associated with this account. So the encrypted ticket in the curb roast file is something that is encrypted with the NTLM hash of the account. So in short, we are scanning Active Directory for user accounts. As you see, we're done, and then we are requesting service tickets, and then we are brute forcing doing the brute force attack on the, for those passwords that are well, basically used to encrypt these tickets. So as you can see, we've got here a situation where we've got a password, and actually we managed to get it. Yeah, so that is pretty cool. Now, the next stage over there is that we will need to having all of that well, used to access a domain, because right now we are in a possession of the password for the account that is SVC AD migration. So that's already like a different stage. And the reason why I'm saying this is because having that, we could be, of course, performing the lateral movement, and that is exactly what we're going to do. And before we do that, we need to know where and how and so on. And for that, we're going to be using the sharp hound. And sharp hound is actually pretty straightforward, and you guys might know it. And this is basically the ways of how we are able to scan the infrastructure for different misconfigurations in Active Directory. Yeah? So let's simply do that. So once we already got that password, yeah, we are at that stage where we've got password done. And we can see that that's the vamos part. Then let's get back, of course, to Windows over there. And the next stage, we're going to be, of course, playing with the account, which is SVC AD migration. Yeah, so we're going to be, of course, using the sharp hound tool, and we're going to be using that one with the option all. And it's going to allow us to get information about the domain. So let's do sharp hound exe. And then there's an option -C all, and this scans the domain and searches for misconfigurations. Yeah, so it actually gets information about users, groups, permissions, and so on. And later, that data is something that we're going to be importing into Bloodhounds so that we are able to perform the analysis. Yeah, so that's going to be pretty cool, because yet again, it could be used by you to analyze what's wrong over there, but also it could be nice to simply well, attack the domain and find all the misconfigurations, all the vulnerabilities, and so on. And the file over there that we got, we're going to be importing later on to Linux, where we're going to be, of course, analyzing on the Bloodhound machine. Yeah, so that's the setup. Yeah, so this is basically done. Now, the next stage over there is to use the Bloodhound part. Yeah, so let's switch back to Linux right now, and our goal is going to be to perform some analysis. So once we got this file, we are able to analyze it, and then you can see that we've got over there SVC AD migrations raccoons. Yeah, so that's the setup. So we are able, of course, to import that file in the Bloodhound, and we can see that also the account SVC AD migration, as you can see, it has permissions, which is generic all. And of course, we can get into details. Yeah, so let's we can do the right click, and then of course we can just do help over there, just to see, of course, the details about that. Yeah, so here we go. You can see that we've got a full control over that particular computer account. So now, of course, it's time for the attack, and let's do it, because we're gonna be right now trying to control this machine, And the question is, of course, how can we do it? Yeah? So that's going to be the interesting part over there. And we're going to be using, for that part, well, PowerShell. So let's do this. And of course, we will be at the next stage leveraging here a situation of the misconfigured permission. So let's move back to the, in this case, Jeremy Brooks machine. And this is the moment where we continue. And from the Jeremy Brooks perspective, we will be actually doing the run-as, and we're going to be running, doing the run-as as that user that we got from the past. Yeah, so that we managed to get. So that's basically the setup. We know, of course, the password of that user, and that's it. Yep. So let's do run-as, and then we've got user, and then we will specify raccoons. And for that, we will be specifying that we've got over there SVC AD migration account. And yeah, we will specify as well that it should be net only. And we've got a PowerShell. So we're going to be starting that console like that. So we know the password, of course, for that user. Yeah, so we got that. And in a moment, we're going to be running, here we go, the password as this user, the console, the PowerShell running as this user. So the next part is just to do get AD computer SRV2 AD migration to get information, of course, about the computer that we have control over. Yeah, just for the reference, remember there was a generic all to that computer. So yeah, that's going to give us a little bit more information that we would need, like properties for the service principal name. So let's do it. Get AD computer, and then SRV2 AD migration. So we got this, and yeah, that's it. This is just basic information. Yeah, so we can see, quite important, DNS hostname over there. Yeah, and that DNS hostname we will specify. So here we're going to do properties, and we will specify the service principal name. So let's do that. Here we go. And this is going to give us information that, yeah, there is service principal name and looks like this. We need this value clean. We need this part to be clean. So we're going to be actually focusing here on the service principal name and also the DNS hostname, because based on that, we will be able to actually generate certificates. Yeah, so that's the setup. So we need this field to be empty. So that's why it will be necessary to work on it a little bit. And we need to have the SPN value, of course, to be clean. So let's just simply do that. Yeah. So for that, we'll be specifying this. And the second thing, of course, to do is going to be to set the name of our computer to ADFS, for example, that we're going to be referring to. So we've got small steps, but still something to do to be able to impersonate the ADFS server over there. Yeah? So that's the setup. So let's put it on. We've got here service principal name at, and then the mustache brackets, and this is the moment where this is cleaned. So that would mean that we can, of course, check on that. We'll need to still update the DNS hostname, but that will mean that we will be able actually to impersonate into other computer in our domain, but that one in a moment. So after running these two, yeah, we can check basically properties of the service principal name and have a look. Yeah, so that's it. So in general, we had over there DNS hostname, SRV2, and so on. And right now we have a DNS hostname ADFS and a service principal name property. It is actually empty. Yeah, so this is what we got. So that's pretty cool. And after we've done that, yeah, we can actually try to run the command cmd on that computer, and we're going to do the run-as that SRV2 migration. Yeah, so that's one of the next steps. So we are like going step by step to eventually reach a situation where we're going to be impersonating ADFS. So we've got a CMD, we can do the run-as, and then we're going to specify the user, and it's going to be raccoons, and that's the SRV2 AD migration. Yeah. And after we got this, let's just do it. We've got net only, and that's basically our CMD that we would like to run. Yeah, so here we go. We are running that one as a user. So we are technically at that moment not having the password, but we will need it. So if we do have full permissions, then what we can do, we can restart a password for that computer. And for that, we're going to be using the set AD account password. And we're going to set it up to password 123. Yeah, so let's put on the command. This is easy. I'm pretty sure that you guys did that already, but it's one of the steps. So let's just put it on. And then we are using here password 123, as you see, convert to secure string. And we've got force. Yeah, so we may also type it in, but this command allows you to see what exactly we are doing. Yeah, perfect. So we've got a password 123. Yeah, and that's it. So bring it on. We can put in password 123. So we are right now fully in control, and that's the command that basically belongs to SRv2 AD migration. Now the next stage is, of course, let's just get into the C tools, and over there we're going to be using the certify, but first we're going to be using certutil so that we can learn what's the name of our certification authority and where we can get the certificate from. Yeah, that's the thing. So this is pretty much our next step to perform a little bit of impersonation. So let's do it. So we get a CD tools, yeah, and certify blank, and then the next part is to use the certutil to learn, of course, this information. So if you wonder how to check what's basically the CA name, then as you can see, it's all perfectly clear. We've got a CA1, a raccoons PL, raccoons issuing CA1. So that is something that we're going to be using right now. Now, right now, we are able to get a certificate from there. So once, of course, we got this, we can actually request for the certificate. And for that, we're going to be using certify. And certify is actually pretty straightforward, pretty easy to use. After that, we're going to be having certificate that we're going to be able to convert in different ways, which of course I will demonstrate. So have a look. Certify, request, then we've got from the certain CA, template, machine. That's it. So we are requesting the certificate of the machine. So perfect. We've got current user context, Jeremy Brooks, having full control. So we are right now having a certificate just like that of that particular machine. So in the name of machine. So that's perfect. Yeah. And we are not running that one as an admin. And that's the best part of it. Yeah. So if you wondered, like, is it possible to be just a user? Yeah. So let's take that particular certificate. And just for the reference, we're going to be storing that. Let's just put it in Notepad. So bring it on. We've got a beginning and the end. I'm going to actually save it. We're going to save it, of course, as the certificate. So that's going to be the ADFS. And let's do .ser. Yeah, so that's what we got. Okay, so we can also check whether we got that in tools. And we do though. So at the end we can check and within the our folder here. So we can go to the folder where we stored it. So that's the temp. We will be seeing that that's the adfs.ser. Okay, so that's it. If we open it, you can see when it was basically set up. Yeah, that's the ADFS raccoons PL though. So we are requesting here for the certificate for the machine that's basically not even related with us. And that's the most beautiful part over there. And as you see, subject, ADFS, raccoons, PL. So that's perfect. If we go into details, yeah, you can also see that subject alternative name, that's also ADFS raccoons PL. So right now we are able to perform the impersonation. Yeah, so here we go. Now the next part is that we will be able to work a little bit more on the certificate as well. So we will be copying right now the whole certificate, and we are able to save it as the PEM. So we can of course check for that, and we're going to be doing this in Notepad. Yeah, that's one of the next parts. And once of course we do it, we will be leveraging this certificate in certify. Yeah, so let's save it as a PEM format. So we get an ADFS, and then let's just do PEM, and that's it in the temporary folder. Perfect. And then of course the next part here is to use the certify to convert it. Now have a look here. It says actually there's a command convert with OpenSSL and so on. So we'll be also using this one. Yeah. So let's do that. So we need of course for that PFX. So let's just put on the command So we got an open SSL and so on. So this is the command that we will need. And we are right now, of course, exporting this into whatever format. Yeah. So this command is just given. Yeah. So we don't have to think too much about that. And that's it. So let me copy it, and then we'll be moving forward. And the next part is yeah, let's see what we got. Yeah, the password. Yeah, perfect. Essentially, we could be right now getting into the Windows box and leveraging, of course, this particular certificate. Yes, we got an ADF XPFS. So let's take it and let's move it into Linux, and then of course we'll be actually doing that attack from the Linux. So let's do ls. Oh yeah, is it okay? So let's do lspfx. And the next part is to see what kind of options we got, and then we will be moving that certificate into the ls/etc Apache 2 certs, so that we are able, of course, to use that particular certificate. So we've got a etc Apache 2 certs, and here we go, so that we are able to use it. Almost there, as you see. And we've got it already over there. And the next part is that we will be putting that certificate for the ADFS. So let's just do for that head and then minus N10. And then we will be specifying the Apache 2 sites enabled. And then, of course, we put it on, we've got it on within the sites. Yeah, so that's it. Within the config, we can list it. And as you can see, this one is already there. Yeah. Now, another part that we need is to, of course, create a good website. And what we will need to do is to do, let's just see the passwords first. So we get a password file. So that's cut pass.txt, because what we need to do is to perform the fake ADFS server. So that's basically the last part. And of course, that's it. So let's do the var HTML, here we go. And then, as you can see, we're going to pass txt, and let's just check it out. Perfect. And in here, our job is going to be to see that, well, first of all, the passwords are empty, but we're going to be receiving them in a moment because users are going to be actually forwarded to our website. And the next part over there is well, to use, of course, the Jeremy Brooks console. Let's just to ping, because what we want to do, we want to cheat users that ADFS is actually under different address. So if you're going to do ping ADFS raccoons.pl, you see that that's the 10.11.21. And obviously, yeah, we will need to do a bit of a job so that users would believe that that's actually not this website. So we could be using some spoofing attacks over there, but we could be also relying on the dynamic DNS updates. And that is for something. We're going to be using the MSF console. So that's Metasploit module. And once it loads, we're going to be just setting up that configuration. Yeah, so we are almost done with this. So long story short, yeah, that's the loading of the module. So we got that. And then we've got in here the possibility to set up the option. So we're going to use the auxiliary admin DNS, DIN DNS update module so that we can, of course, perform these updates. Yeah, so that's the Metasploit way of doing that. Yeah. And now, of course, Metasploit is free, so you can also have fun with it. So let's do it. Use auxiliary admin DNS DIN DNS update. We got this, and then we're gonna do show options. Yep. So we can check what we got, and that's not much set. Okay. So just tiny part. Yeah, we will do set domain raccoons.pl. So let's do that because that's gonna be, of course, our domain. And then the next part is to do set hostname ADFS. Perfect. And then we will need to specify our IP address, which is our attacking IP address. So that's the attacker's IP address. We are doing the set IP, and that's the 10.1.1.250. So that's the attacker's address, okay? And the next part, we're going to do set our host, and that's going to be the IP address of the server that we are going to attack. Yeah, so that's the case. So that DNS we are going to attack. So that's basically our domain controller, which hosts DNS in this case. And then let's do show options. And then as you see, all of that is set up. We can see that, of course, the ADFS name, so raccoons, it has been updated. And then we just run, and that's it. So we've got, we are relying here on the DNS dynamic updates, and then you can see that that's done. Yeah, so we've got here that the name has been added. So right now, ADFS raccoons PL, it is actually poisoned. So we can check whether this is true, because we'll find that it's written, but it will be great to verify. And then we do ping ADFS raccoons PL, and as you see, that works. So we've got a 10.1.1.50 right now. So we are pretty much finishing up because we've got all the details in place. Yeah, I know that you're waiting for all the rest of the guys, so let me just run this one to the end. And exciting moment, because of course we're going to be leveraging this ADFS part, and the next part, it's going to be to for example, go to Windows box over there as we are, and then from that perspective, we will be, of course, checking on the details. Yeah, so just one more part here. We can just do exit. That's it, just to keep it clean. And that's it. We can do cut password just in case. You can see it's empty. Okay, so it's all clear. And then in the Windows box, we will be right now going into the ADFS web page, which is of course very secure because it has obviously all the details like a padlock and certificate and so on. But don't forget, it's a certificate that we have actually requested for, so it's real but kind of fake, and of course users. Yeah, so what we're going to be doing over there, well, we could be using the George Carter, for example. Yes, one of the users, and George Carter at raccoons.pl. So bring it on, and the George Carter is going to be entering some password. Yeah, that's going to be some whatever secure password 1 or something. Yeah, and we can check that so that you guys can see. So all is clear, and we have, well, one more thing. We're going to be signing in, and then just for that. One more detail, we're going to be putting on, let's say, Paul Ramirez, for example, yeah, as one of the users that we got. So Paul Ramirez is logging on. And the next part, so of course, at raccoons, let's do that. And then the next part, of course, it's to do the another secure password -123 or something, and it's a very secure password, as you see, and bring it on, and then let's just to sign in. And this is the moment where we can just simply do once again cut pass1, and what we are learning over there is that we've got, of course, all of these passwords in from the user's domain. Yeah, so lots of details, but definitely something that allows us to connect the dots first. And just by the simple human thing, we were able, of course, to attack this big piece of infrastructure. And at the end, we will be impersonating into other users. And then finally, hopefully, suddenly somewhere, we'll be able to get into domain admin. But okay, if you got any questions, put them on the chat, because I cannot take longer. My time slot already took it a little longer, because right now it's time for Sami and legacy configuration, or maybe misconfiguration. So Sami, I'm giving you back the stage. Stage is yours.
Thank you.
Perfect.
Let me see.
Yep, we got your screen.
Great. I was gonna start this by pretending to be an AI copy of myself, but maybe I won't do that today. I will take a complete blue hat approach to this. So what I am gonna go through is, I think, a big misconfiguration for any environment today, which is in a world of more than 1 million pieces of malware found per day, it's insane to think that you could protect yourself by using things like antivirus or anti-malware. I think Michael once said it very well in one of our sessions that you already have a blacklisting solution or deny listing solution, and that's your antivirus. So the thing to actually use for protecting your environment needs to be whitelisting, nowadays called allow listing. It'll take me as long to call it allow listing and not whitelisting as it will take me to call it Entra ID and not Azure AD. I am gonna speak through what I do as a consultant almost every week. Today, every day I've been architecting different projects for different companies on the concept of allow listing and mainly currently AppLocker. So I will try to give you real life examples, real life tips on how to actually make a successful project. Now, so AppLocker, why is it now the most used one? Well, during last year, they changed the licensing model so that you can now use it for Pro as well. It used to be enterprise only. I can't sadly take credit for that. I thought that my lobbying for the past, what is it, like 14 years that I have explained Microsoft that they need to allow it for professional licensing. I thought that finally my lobbying was actually the one that made this work on a Pro, but it's sad to say that I actually had nothing to do with this. So it's a very sad story or a funny story. So Microsoft actually has a unsolved bug with Windows 10 and Windows 11, where if you activate your licenses through the cloud, there are cases where your enterprise version of Windows drops down back to a Pro. Now, this would mean that if you had enterprise running everywhere and then you would start protecting yourself with AppLocker, then suddenly your computers lose their enterprise license, which means that your allow listing would completely die. And this means that to mitigate this unsolved bug, Microsoft allowed AppLocker to run on the Pro as well, so people would not face the consequences of dropping out of license. But anyway, I don't care how it was done. Main thing it's done. There's another tool everyone's speaking about. It used to be called Device Guard, then Microsoft renamed it to Windows Defender Application Control, then they renamed it to Microsoft Defender Application Control, and now last week they renamed it App Control for Business. So they really can't come up with a name. It's a solution that runs on the hypervisor. So the hypervisor sets memory pages to executable or not, which means that you can only have one rule set per machine. And that means that that will be a single purpose machine. You really can't build a system where your admins can run Process Explorer or Process Hacker if they want to, but everyone has the same rules. So you can't build a system where limited users can't use things that more privileged users can. So you can't have roles for people. So that means it's great for ATMs. It's great for anything that you shoot missiles with, if you ask me. So I don't like it at all. But AppLocker, on the other hand, can give us everything that we need. So let's talk through that. If you are not being able to manage it on Pro or actually run it on a Pro, then you might need a KP article that I listed here already. First of all, whenever you start the project by limiting executables, MSI, scripts, and package tabs. I know more than well that you cannot build a secure AppLocker without taking care of DLLs. So your ransomware would use a DLL instead of an executable, so we have to take care of it. It's not that. But the thing is that if you launch Notepad on Windows, you will get one log entry. If you are monitoring for DLLs at the same time, in the first phase of your project, that means that every time you launch Notepad, you'll get around 50 log entries. Now, the problem with this is that you have a lot of things to do with the AppLocker project. You have to first figure out and audit what you're running. You have to build rules based on that. You have to teach your service desk. You have to build processes for software lifecycle management. There's a lot of things to do, and many of those are actually processes involving your company and your employees, which means that if you first hit yourself with, let's say, 200 megs of log for during a few days, which would be quite normal in the beginning for AppLocker in a, let's say, 6 to 10,000 client company or endpoint company. If you would hit yourself with that, that's a lot. That's going to be hundreds of thousands of lines that you have to filter out. And there's a lot to do anyway, but think about multiplying that with 50. Your first touch base with your allow listing project, when you go to your first meeting and you start your Excel and you're hit with 70 lines to look at for every application that you launched, you're going to drown yourself in log data. I have tried this. Been there, done that, bought the t-shirt. I've done it, and I will never do it that way again. So what I will tell you as a very strict recommendation for me, if I'm going to run the project, then it's always that we start with executables, MSIs, scripts, modern apps or universal apps, and we learn to live with AppLocker. And then when we ran the project through and you got everything sorted out, your service desk knows how to react when something doesn't work. Then when you have everything done, then you are capable of handling a log data that will be that big. Most of it will actually be taken care of because you've already kind of added publishers and stuff like that. So you have to make the DLL rules, otherwise AppLocker will not be safe. But do it as the last step. So make everything run, make a fluently running engine in your company that can take care of AppLocker. And when you're at that phase, then you're ready for the DLLs. If you run an AppLocker project where you are hit with this very usual and very common misconcept, which is people telling me that we don't want to have AppLocker because it's so much work. If you, before you start hitting those DLLs, if you are in a situation where your company needs to work more after installing AppLocker, something's very wrong. I have never run a project that did not take down the amount of work after we implemented AppLocker. Because think about it, if you let anyone install whatever you want and you have to support everything compared to the situation where you list that these are company allowed applications, your service desk knows how to handle them. If your job in the bigger picture, I mean, if the amount of work does not go down, something's done wrong. It always takes down the amount of work you have to do on the reactive side, that where you spend money on the proactive side. Also, I have these when I go in and people ask me in a meeting that, Sami, we have a plan that we're going to hire 2 new people so that they can take care of AppLocker. And they ask me if I agree, and I always say I disagree. I think you should fire a few because you will take down the amount of work. It's the same principle as getting rid of admin rights. I mean, if you have to work more after getting rid of admin rights, you did something wrong. Because this is the assumption that people think that if I don't have admin rights, I can't fix my computer. But from the company level, it's about the fact that as long as you don't have admin rights, you can't break your computer. So it's you have to see the bigger picture there. But anyway, so first start off with everything else except DLLs and then add DLLs at the very end. Please. One thing people do not understand how AppLocker works and they don't take the benefit of using AppLocker correctly is inheritance. So people do not understand that you should be combining many policies. You have a top-level policy that hardens every other policy. You have a top-level policy for rules only. You have another policy that sets whether it's audited or enforced. There is a very, very easy way of making this easy to manage, but people don't use, and I didn't in the beginning either. So what I ended up doing was I would have 2 rule sets. I would have rule sets that has 200 lines of applications, and then it would be set to enforced. If I now need to get that computer fast into a troubleshooting mode, I need to change it to an audit mode. Think about it. So what if you have, just think about it this way. what if we have a blah, 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 blah. Let's say we have a rule set here. So this is rules 1, and this one says allow app 1, allow app 2, and so on, okay? And you are going to set this into enforced, let's say. Then you are going to want to sometimes run those rules, but you need to only audit because you're experiencing a problem with it. So then you would have another one. And this would mean that this one here, oops, sorry. So this would mean that this one here would be like enforced mode. And then you would have another one down here that would be audit only. Okay. So now if you need to change someone into auditing, you could change the policy that applies to them. But what if you need to allow, what if you need to add app 3? This would mean that you would have to go into here. I would allow app 3, and then you have to go down here as well. Okay, so I will have to go. So you're managing 2 places. Why? Stop. Okay, you're managing 2 lists of hundreds of things. Don't do it like this. So instead of this, what you do is this. And this means that we have a, first we have this one here. This will actually only ever contain deny rules because we're going to harden app locker against your living off the land binaries. We can't allow install util to run because install util will bypass app locker. But that protection applies to every app locker that you ever do, which means that you should not put it into every rule set as a deny rule, because then you have to manage every rule set. Okay, so you only put deny rules into this. This will be your hardening policy. Okay, now this is hardening policy, let's call it that way. Then what you're going to do is you're going to have this one here, and probably you have some other different departments, different kinds of computers. However, you're going to have your kind of like your main app locker policy here. And this one will only contain allow rules. Okay, so this is where you tell which apps are good for us. Now, app locker, how it works is it merges the rules, which means that now if I go and change either one of these allow rule sets, they will be always merged with the deny rule set. But you don't have to go and type 100 deny rules to every app locker rule set. You just do it on the top so that it's easy to do. It will merge to every other policy. Then you have one more, this one, or this one, or in this case, this one as well. And these are apps that will just set the mode. Okay, so this only has either audit or enforce. So only the main switch. Only the main switch, whether how are you running app locker, which means now that you have the last combination of all of the rules with the inheritance, you have one top level that gives you all the protections for everyone for app locker protection itself. I mean, protecting app locker itself against lolbins. Then you have the allow rules. And now you only have a switch that marks it whether it's enforced or audited, which means that when you need to change the rules that you need to either enforce or audit, you only edit one place. I'm lazy. I don't like extra work. Okay. One other thing that is on this screen that might make people wonder, it's only because of COVID. So one sad thing is that we had to change. We used to do this with computer groups a lot, and now you see that you have these audit only OUs. Why is this an OU? It's an OU because OUs are the only things that will update your group policies. Someone said on the chat already that I love GP updates /force. I've been thinking about making a t-shirt like "May GP updates less force be with you." That would be so cool. I love it as well. But GP updates less force. The problem is that if you do this with computer accounts, and now when COVID started, people went to work from home. That means they're using most of them a user level VPN tunnel, which means you cannot update those computer group memberships because they get updated during a boot. An OU hierarchy is the only way to filter group policy, applying a group policy. The only way to filter so that it every time works through a user level VPN is actually an OU. If you use computer account, it requires a shutdown. If you use user logon, it's going to require a log off. OUs will always work. And even without the force, it's amazing. If you do not know what's the difference between GP update and GP update / force, it's only been there for 23 years. So GP update reads policies that have changed. So the version number of the policy has changed, but GP update / force reads all policies whether they have changed or not. Now the problem is that GP update is never run by Windows except for security settings, client-side extension every 16 hours. So it's never run. That's why it works. That's why it fixes everything. All right. My current app locker. Few things. I want to get this out there. Don't be a hypocrite. There is nothing more silly than having a conversation with a customer who says, "Sami, we don't like this. You have your policy here. The problem, everything else here seems to be fine, but we have an issue with this because Sami, we will never ever be able to trust Microsoft for all their binary." And I'm always like, dude, I'm fine with that, as long as we install Linux. Because if you're running Windows operating system and you're saying you don't trust Microsoft certificate for all signed binary that they provide to you, that's hypocrite, okay? I can't trust Microsoft, but I run Windows. That's like the same thing. I don't trust Apple, but I run an Apple computer. I mean, come on. Then when I tell them that the next thing we will trust will be this one here, we will trust everything from HP. And they will be, no, oh no, Sami, no, absolutely not. We cannot trust HP. They have installed a keylogger in the audio driver. We will never be able to trust HP. I'm fine, but then we sell the HP computers and buy Lenovo. Because if you're not trusting the company that builds your laptop that can run code in not just ring -1, one below your kernel, but in ring -2, 2 rings below your kernel, that's even more hypocrite. So if you're sitting here, I'm sitting here with a Lenovo and I am running Windows. And if I'm going to say I'm not going to trust Microsoft or Lenovo, I will sell this, buy an HP and install Linux. Then I agree with you, okay? So don't make this too complicated. Whenever you have your ad blocker rules, you have to remember that many application developers don't do their job very well, which means that they will allow people to write into program files, which is completely disallowed by all instructions that Microsoft has ever made for developers. So that is insane, but they do it. Like on my machine, for example, the biggest problem is SQL reporting. So SQL creates memory dumps and puts them in the program files, although you're not supposed to put any data in program files, which means that I can't allow everything from program files by just removing people's admin rights, because even non-admins can put things into SQL memory dumps. And then they run their Firefox through there. So we have to make sure that our rules don't leak. And that's where you use access check. So that's when you'll do, like on my machine, we can do a simple one here. Access check for limited users in C program files. This is a sysinternals free tool. Then it says that some things it can't check, but these are the problematic ones here. So Microsoft SQL Server, thanks Microsoft for building instructions for all the developers that never find those instructions, but thank you also for not telling your own developers to read your own instructions. But anyway, then we have TeamViewer here as well, because this is very typical. You put things in program files and then there's a log file, but oh my God, someone removed admin rights. So now they can't write to the log files. So they allow these to be changed by limited users. It is insanity. TeamViewer actually fixes it in a little different way. I always do it this way if I can, so I'll make an exception and say, okay, allow everything from C program files except. Here's my rule set. I've been running AppLocker now for, well, software restriction policy included. I've been running it now for 20 years. So still, this is my list. It's not that bad, okay? Now, if you look at my program files rule set here, there is an exception here. I can't allow anything from SQL Server, shared error dumps, because the problem is that there are limited users could put their Firefox here. I can't allow Firefox. Some limits to everything. And then I have to do it for two different things because there's a known weakness against AppLocker where you have to also kill the alternate data streams that NTFS supports also for the file with an attribute D, which we know as a folder. And then that'll be secure. Another way of doing this would be the TeamViewer way. And the TeamViewer way would be to, there's my, I'll show you this, and this will be C program files, TeamViewer. And you can find the log files here that I spoke about. Oh my God, these guys are genius. I mean, developers will do whatever it takes to not have to follow the rules and change the way they develop things. Because the correct way to fix this would be, of course, to move your log files out of program files. But no, for sure not. The developer will find a way. Explicit deny towards the world for execute file. Okay, so even if you put binary into the log file, you can't execute it. Genius. Yet I would prefer if you just like obeyed the rules and not put them in program files, but in program data. But anyway, that's one way of getting away from that. At some point, you will be faced with the fact that you have to do rules like this. See users, anyone, update the local application, anything, and then you will have security people who will yell at you, and they will tell you that, oh my God, Sami, we cannot do this because now AppLocker leaks. And that's when you have to remember that in security, don't let perfect be the enemy of good. And also you have to remember that your job nowadays is not prevent the enemy. Your job is to slow them down. We slow them down so much that our reactive security can catch them. Think about this. If I tell them that there's one location where you can run things even if you're not an admin, and then there are people who say, hey, ransomware with PowerShell, it takes like 2 seconds to go through every folder and see where they can put stuff and run it. Now that's the great thing. That's awesome. Because that means that they behave very weird by doing an access check against a gazillion different directories, which looks suspicious and SOC, and especially your EDR and XDR can catch it. So we slow them down going through your different barriers. I would be so much more happier if you build 6 95% proof solutions on top of each other than banging your head for next 6 months trying to build 100%, because that doesn't exist. And that's not even your job anymore. Your job nowadays is not to stop the enemy, but to slow them down. I leave this here with everything that I just said. Stick to containers, stay away from items. If you find yourself listing 800 applications inside of program files for hash values, you're going south, you're going to lose the war. Rather, allow program files, remove admin rights. One rule, not 800, and you actually get a manageable solution that you are happy with. I have customers that have lived with my solution now for 14 years, which is awesome. But I only went over 3 minutes, so I'm better. Okay, thanks. Back to you, Paula.
Thank you so much, Sami. Fantastic. Yeah, so let me use this momentum to also announce Michelle Grafnetter, and that's something that I'm also very much looking forward to, because Michelle's going to be talking about quite a lot of details in terms of different attacks on Active Directory. As you know, that this is also his specialty, and yeah. So what we got. So I think it's time for a little bit of screen sharing. So I'm giving the stage back to you, and let me see. So you've started the screen share, all good on the screen. So let's start.
Thank you, Paula, and hello, everybody again. Let's talk about a couple of security features in Active Directory and about a couple of attacks against them. So the first one will be offline golden GMSA attack. Then we are going to look at how access control lists are configured on DNS zones by default. And we will finish by looking at Credential Guard and at a couple of ways of bypassing Credential Guard if it is enabled on computers. So let's start with the offline golden GMSA attack, the latest, newest addition to the DS Internals PowerShell module. So as a reminder, a GMSA or Group Managed Service Account, a feature that was introduced in Active Directory in Windows Server 2012, where there is this special account for which Active Directory automatically manages the password. For you to be able to use that feature, you need to have at least one KDS root key, which is a master encryption key that is used for password derivation for these accounts. And you can then freely use such accounts as an identity for either services or scheduled tasks or IIS application pools. And it's even more convenient for administrators because you don't need to type the password everywhere. And it is also more secure because it changes the password on a monthly basis by default. And now let's look what you can do with the GMSA accounts using the latest version of DS Internals. So this new command has been added there in version 4.12. It's called get80db service account. And now we are presuming that the attacker was already able to get their hands on the ntdsdit file, on the Active Directory database file, which of course is a huge, huge problem. And you can already consider the environment to be compromised. Well, I was able to do that multiple times when doing penetration tests, where I just discovered some backups or virtual machine snapshot, which were just not protected. They were not treated as the live production system as they should have been treated. So you just load the Active Directory database, and this command will automatically read all the KDS root keys, all the group managed service accounts. It will combine the information together. It will combine it with the encryption keys, and it will show you some interesting information about the account. So it will show you how often the password is generated, what was the last KDS root key used to generate the password of this account, and so on. And it then also calculates the current password based on the current time or the specific time you provide to this tool. And it will show you the NT hash, and it will show you the proper Kerberos keys. So even if this backup of the ntdsdit file is very old, like, I don't know, a year, 2 years, and the company hasn't touched the KDS root keys since, which most organizations do not do, then this calculation would still be correct, and it would still give you the current latest password or password hash of this account. And here in this specific demo, we are looking at the GMSA account of Active Directory Federation Services, because ADFS by default uses GMSA accounts. How can you then use those stolen credentials or those calculated credentials? Well, you can either directly log into Active Directory as that particular service, but in this case, it would be much nicer to do the silver ticket attack. So using a tool like Rubius or Mimikatz or some other Linux tool, you can generate your own service ticket into which you would inject user information, and you would then encrypt it using that calculated AES-256 key, and you will get a Kerberos ticket. And through the PTT parameter, it would be injected into the memory of your computer. And then you can freely open the browser and visit the target service. And in this case, it would be Active Directory Federation Services with Windows integrated authentication, and it would automatically sign you in. You would also see it in the event logs that we are really impersonating the user account, which was specified as the parameter when generating that silver ticket. You can also spoof group membership. You can say that you are administrator, that you are a member of whatever group. And if this Active Directory Federation server is connected to any sensitive service, even to a cloud service like Office 365 or Entra ID in general, you can then impersonate any hybrid user, even in the cloud environment. So this is a good way of jumping from on-prem to the cloud environment. Let's look at the second thing I'd like to note, and that is abuse of default access control lists on Active Directory integrated DNS zones, because no one ever looks into these ACLs. Most people haven't analyzed them. Okay, so again, we are talking about AD integrated DNS, which is replicated through the same protocols which are used for regular Active Directory object replication. And the DNS records are located on the domain controllers in the database. And if you then open the DNS zone object and you look into the access control list using this not so good user interface, which is present in Windows, you will see a couple of interesting default records. So let's start with the record at the bottom. It gives the pre-Windows 2000 compatible access group the list contents permission, so they can basically read everything from here. Who is a member of this group? Well, by default, authenticated users. But even if you remove the authenticated users from this group, the case is still lost, because you then look at the next record, which says everyone has a special permission, and if you click through, you would see that special means read everything from here. So that's also not the best thing to have there. And it can get even worse because the line above says that authenticated users can create all child objects. So now let's try to misuse these default permissions. And we are going to use a set of scripts from the ADDNS dump project, where you can first authenticate against the LDAP protocol running on a domain controller using a regular user account. And you can list all those DNS integrated zones, and the output you will get is basically what you would find in on domain controllers in the DNS application partition. Yeah, so you get the same output. And once you know the list of DNS zones, you can look at specific records inside of a specific zone. And again, you will get the list of all the computers, list of all of the IP addresses of the computers. And yes, regular users could even search for computer objects in the domain partition. But the advantage of this approach through DNS is that most of the time you will also get Linux computers, yeah, non-Windows devices, which are also present in DNS. So you would get a much bigger picture of the situation. And let's try to use or misuse the last permission which is there, and that is the permission to create new DNS records. And I do not want to create just a regular record. I will create a wildcard record. It will save me some time, because instead of creating 10 different records for each and every fake server possible, I will just get everything with this record. And again, even regular users can do this, and the attacker would redirect that wildcard record onto its own IP address. And this is how the record then would look like in DNS. Most organizations, most companies are not looking into these records. They do not have monitoring that someone has created a wildcard record. Well, engineers at Microsoft thought about this, and they implemented one countermeasure against some impersonation attacks. And if you look at the default configuration of DNS servers, there is this global query block list, which contains two records, WPAD and iSetup. And these two records can never be impersonated or created by regular users, or even if they are created, the DNS server won't serve these records. It won't respond until you remove the records from the global query block list. iSetup, that is already a deprecated feature, a transitioning feature between IPv4 and IPv6. WPAD is more interesting. That's web proxy auto discovery protocol. So unfortunately, we cannot misuse that. But still, with the wildcard record, you can impersonate so many other computers. You can start doing NTLM relay attacks or other identity-based attacks, and you can just start impersonating any website which might be in the environment. It's enough that the user either mistypes the address or they have DNS misconfigured, and you will be getting so many queries. I'm talking from experience. And the resistance is really futile here, because these attacks would work even if you remove authenticated users from pre-Windows 2000 compatible access. And also, even if you disable dynamic DNS updates, if you switch it to none, the attack would still work. A malicious actor would still be able to create that wildcard record, because they are not using the DNS service for that. They are using the LDAP protocol to create the records. Okay, so that setting is really unnecessary there. And now let's look at a couple of ways of bypassing Credential Guard. Because with Windows 11, Microsoft started to enable Credential Guard by default. And similarly to AppLocker, it also started to work not just on Windows Enterprise editions, but also on Windows Professional editions. So you are going to see Credential Guard deployments more often now than it used to be a couple of years ago. So this feature is there to isolate user credentials like NT hashes or Kerberos keys in a separate part of the memory, so that tools like Mimikatz and others cannot access these credentials. Well, Credential Guard doesn't protect all credential types. So it doesn't protect the PIN code for your smart card, for example, or it doesn't protect data protection API encryption keys. So people could still steal your Google Chrome passwords or cookies from Microsoft Edge browser and so on. But then other technologies are also deployed by companies like LSA Protected Process, or the newer Microsoft Defender attack surface reduction, which can also protect the LSAS process. And dumping credentials from LSAS is thus becoming much harder and harder than it used to be in the old times. Well, fortunately, there are still ways to get past it. And of course, the easiest way is to just deploy a keylogger to a compromised machine, because all the credentials go through user space before they get into that special part of memory, before they start being protected by the credential guard. So even with credential guard, keyloggers still work. Now, one of the things which is quite commonly performed by attackers is the pass the ticket attack. You first extract the ticket from the LSAS memory, and then you import it onto another computer and use it to authenticate against the service or against a domain controller. And that can actually still be done even if credential guard is enabled. So let me show you how. So we will start by using the built-in command in Windows, klist sessions, and we can see that an administrator, well, in this case, a domain administrator, has a session against this computer. It would typically be a remote desktop protocol session, but it could also come from PSExec or from some other tools. So we can then again use the klist command to list the tickets, but not from our session, not from the current session, but from the session of that other user. And we see that there is a service ticket for accessing the file server. And service tickets are not protected by credential guard. Only ticket granting tickets are protected by credential guard. If that is not enough, if we wanted to get an additional ticket, well, we can send a request through that session of the other user, and we can ask for the host ticket for a domain controller. That could be used for Windows remote management, sometimes even for remote desktop protocol and so on. And that ticket gets automatically loaded from a domain controller into that session of the other user. And after grooming a couple of tickets, the harvest can start, and we are going to use this tool called Rubius again, where we can dump either a specific ticket or multiple tickets from a specified user session or from a specified logon session. And here we are going to get the ticket data, but now including the encryption keys or including the session keys of those tickets. Then there are some additional secrets in Windows which are not protected by credential guard at all, so you can still dump them from the hard drive from their authoritative store. And one such location is the SAM database, the list of local user accounts, so you can still use either Impacket or Mimikatz or some other tool to just dump those credentials. The offline cache of password verifiers, the MS-Cache v2, is also still available in the registry, and it can still be stolen. And credential guard doesn't protect the password of the computer itself either, so you can again impersonate the computer for which you have local administrative permissions. And what is also nice is the remote desktop protocol and the remote desktop connection client in Windows, you know, the MSTSC. Once you connect to a remote server and you type credentials, well, it will cache your password in the memory of the RDP client, so that if your session disconnects, so that you can quickly reconnect without retyping your password. And you can then use tools like Mimikatz or some other tools to just look into the memory of this remote desktop connection client, and it can dump the passwords from the memory of the active sessions. And again, this even works if you have credential guard feature enabled on your computer. And third-party tools like Citrix and others behave in a very, very similar manner. So really be careful where you type your credentials. Do not rely on credential guard. Use remote desktop protocol in restricted admin mode or with remote credential guard, so that your credentials are not cached in the memory of the MS-DSC process. So that's it. We first looked at the offline golden GMSA attack. Remember that you should periodically rotate your KDS root keys and that you should change them at least after a suspicion of a compromise of your Active Directory environment. It also makes sense to look into the default access control lists of your DNS zones and to reconfigure them so that only your computers can create DNS records, or even better, so that your DHCP servers can only create DNS records, but not the regular computers. And privileged access workstations are not that. You should still only be typing your credentials from trusted computers only, so that malware cannot get your credentials. Yeah, because if you execute some malware on your computer, it's no longer your computer. The computer follows the instructions of the author of that malware. So application whitelisting is really, really important, as Sami has already said. So that's it. That's what I wanted to share with you today. So leading it up to you, Paula. Thanks.
Yeah, thank you so much right now, Michelle. Thank you. As always, fantastic. And there are also some questions. If you want to share some answers on the chat, please go ahead. And now it's time to learn how to prevent all of this and how we are able to monitor, spot, of course, all of the attacks. And Peter, of course, I'm giving you the stage.
Yeah, thanks, Paula. So as you saw, all guys like Sami, Michael, and Paula show you that we don't have a simple life and easy life. So blue team is always, let's say, needs some additional intervention from the Chuck Norris, I believe, to protect all those systems. And I would like to start with something which is, let's say, like a summary. What was already shown by shot by Paula. Okay, so let me start with first example, which I would like to show you today, and it's a case of the, let's say, network pen test for the Active Directory. From the blue team perspective, what you already saw, it was like simple techniques to check with some enumeration from the Kali host of the, let's say, SMB protocol. We also tried to use the simple spray painting with the, let's say, tools like crackmap exec. But what you saw, we have many methods which are very useful, like the poisoning of the infrastructure. And that's a really good question on the blue team side. How we should react to this kind of incidents, because it's not only the logs, from the domain controller, from all our, let's say, servers which we have, but we should have much more bigger visibility about what was done on the network side. Maybe we observe something like the poisoning of the, LMNR or different things which should be disabled, and it was not done by the, let's say, blue team at this stage. So if you already grab the credential, what we saw, there is another stage where we try to, let's say, obtain access to different things like SMB shares. Still, we can see that many organizations did not even protect this kind of simple thing like SMB. So oversharing is very common. Like, you can find there a lot of instruction, a lot of, useful details, even sometimes certificates for the domain controller. So what you could expect in the next stage. So Paula already showed you some issues with the, let's say, certificate templates. And after that, it was possible to generate a certificate. But if we have an option like to, obtain the certificate PFX, and after that we can crack it. So we have a huge power, because after that we can use even reviews to request for the domain admin, and that's a really quick action inside the domain environment. So we can say that we have a lot of low-hanging fruits, as you know, inside the domain. So we can try to, exploit different servers with the, like Exchange with the proxy shell, proxy logon vulnerabilities. We have still a lot of production hosts which are on the really old operating systems, and they should be protected, in the dedicated VLANs without any option to hop from the corporate network to this kind of stuff. But it still happens. So you can, reach the host which is still in the, let's say, corporate network, and we have full access from this machine to let's say, production environment. So after that, we can see something like, common exploits to quickly access the, let's say, vulnerable hosts. So if I would like to recommend something, because you already heard about the whitelisting, about let's say, potential to protect with some additional techniques LSAS memory. But I would like to just start maybe with the recommendation, what is really possible if you have Microsoft EDR, because after that, we could even start with the basics. So you saw on the network attack diagram that we still have a lot of problems with basic things which are not fixed inside the environment. So the good example, what you could very quickly configure inside your environment is probably the baseline. So the part of the EDR, like Microsoft 365 Defender, allows you to configure dedicated profiles. So we have a CIS benchmarks, we have a STIG. So the first thing which I would like to see and to review inside my environment is probably the basic, like, let's check how it looks if we already realize the right hardening on our, let's say, servers and devices. So that's the first thing which I recommend. Like, you should follow the, let's say, guidance, like configure the new profile, which you could do it here. And after that, we have great visibility, like how many hosts are not compliant with our, let's say, policies, which are able to, let's say, kill or stop the attacker with, let's say, very simple techniques which are used here. So we have a lot of good things which you could do by just enable baselines here for the Windows operating system. So that's the first step. After that, you saw that Paula, for example, show us Bloodhound. This one is pretty good. Like, even if you have obfuscation of the Bloodhounds, or your version of this one, like recompiled version of the Sharphound, you have a lot of possibilities, to execute this kind of attack from the, let's say, from the Kali host, or maybe there is a Linux subsystem on your machines in the domain. There is also a possibility that someone just, is able to disable the antivirus tampering, and after that execute this kind of pretty good stuff like Sharphound. So what you can see, if you have tools like,
just one question to repeat, because some of the guys are asking so that you can enlarge that diagram, because it's absolutely interesting, just to be on the safe side, so that everybody can possibly reach it later.
Sure. Sure, I will share after my speech in the chat window, so you can see after that. But what is really useful, we have techniques which allows you, for example, with MC, to detect something like the execution of the pattern which is used by the Sharphound. So if you know how it works, or what are the, let's say, simple LDAP filters which are used by the Sharphound, we could utilize Sentinel here in two ways. The first one, I can build something which is called the hunting query. So you have this section like hunting, and here you could imagine that we just download some examples of the, let's say, from Microsoft GitHub, how to detect LDAP queries. And after that, I can execute this kind of hunting query. You can see that Mike here configure 4 different queries which I could just run in the one-shot operation. So like we need to find some DNS URI queries because maybe there is something strange with the DNS tunneling which was used, or maybe we have something like the password reset operation or many other things. It may be the great example with the Bloodhound. So what we would like to suggest here, if you have the knowledge, like what is the basic operation which is executed by, for example, CrackMap exec with different filters, like, you know, SMB search, a lot of, let's say, adversaries are able to use CrackMap to search for WinRM machines, to search for RDP, and after that combine this kind of you know, technique, like I already gain access to one credential and I will search for the WinRM and which machines are accessible for me with this kind of query. So if I know what is the, you know, common pattern, I could build some hunting query. That's the first thing. And the second one is analytic rule. So if you have a Sentinel, we could try to find some very useful, let's say, queries here and just search for, let's say, goodies which are already created by the community. Because Sentinel, if you start with this product, it's like the empty box. So, of course, we have some TI rules which you could enable by default. If you add some connectors, for example, for the Active Directory, like we would like to have all visibility from the, you know, DNS, like from Windows forwarded events, from Windows security logs. So I can say that if I have this knowledge in one box, I could build the right, let's say, analytic rules. And this is the typical job of the SOC analyst. So you need to be aware how to configure this analytic rules. And after that, we should expect that we have this incident which was generated. So let me show you one example, which is pretty similar to what Paula already showed you. So we have multi-stage incident here with the privilege escalation. And what I can find here in this place on the right side, there is a mapping of the MITRE tactics. So we could see very quickly, you know, that we have here credential access. So probably someone tried to touch the LSAS process. And now I can very quickly validate what is the source of this communicate. So I'm quite sure that it's from EDR. It's from Microsoft 365 Defender. So we can jump or pivot to this section to very quickly check what was done on the specific host. And during the SOC analyst course, you can see how to build this, you know, data connectors, like how to add dedicated rules which are combined and glued together with the, let's say, connectors. And after that, how we should tune analytics. So that's the really important parts which you could do here. And of course, due to the fact that on the specific incident, you have also the MITRE framework, let's say, mapping, we could check additional section which is here and verify, for example, based on this diagram which I show you at the beginning of the story, which tactics are not yet covered by our rules. So if you switch quickly to the, you know, MITRE attack preview, you will see the mapping, like a big table, which show you all discovery rules, the hunting queries. And let's say if I would like to check what was already done inside the persistence, like account manipulation technique, you know, or create an account, you can very quickly check what was done here, like how many, let's say, schedule rules we already configured. You can check, you can tune those rules. So the good example how you should deal with this MITRE attack framework mapping is like you need to understand what was already visible, and based on those rules, we should, let's say, map those analytic rules to the right MITRE attack, let's say, framework. Because after that, you may build the whole coverage of all possible tactics which are used by attacker. So just to summarize this section with Sentinel, we are able to track this kind of, let's say, multi-stage attack, which Paula showed us. So if I click here, view full details of the incident, we are able to quickly use filtering and search for some high severity alerts. So let me show you how it works. You have this filtering here and a lot of alerts which are generated and combined inside the one incident. And I'm not interested with this, severity like low, because I would like to first check what is really bad here inside this organization. So what you can see on the list, the first one was attempt to turn off Microsoft Defender antivirus. So method like tampering. And if you click this specific alert, you could check even articles from Microsoft Defender Threat Intelligence, how this method is used by different adversaries, by different APT groups on the market. So if you click this one to learn more and understand how they are using this kind of technique, so now we will pivot and navigate to the section which is called Threat Intelligence in this portal. So I'm really, let's say, interested to see like what we should expect from this technique. So we just opened the antivirus tampering, of course, technique, and you can see here what kind of entries inside the registry are expected, what is the next phase, like when this, let's say, malicious script was executed, what kind of tools are combined or used by the specific APT players on the market to execute this kind of payload. And of course, recommendation, what you should do, like be sure that tamper protection, for example, is enabled on all hosts. But it's not only one rule, like you have a lot of recommendation which should be done here. So just to close this section, during the SOC analyst course, you can see what kind of, let's say, possible detection rules you can build to detect some potential, let's say, attacks on the Active Directory. We have the Kerberoasting, which was shown by Paula. So based on this one, we could see which, let's say, source already provide us the truth about this Kerberoasting. So it was Defender for Endpoint, and probably AMSI already tried to understand what was executed inside the script, like using in-packet or different tools. We observe this, Kerberoasting activity. So that's the part with Sentinel. And another one which may be very useful for you is threat analytics. So we have here for SOC analyst tool, which is called Intel Explorer. And after that, I would like to search for specific, let's say, APT, like Intel profiles of the, nation groups or specific, let's say, ransomware group activities. So if we open this feature, you have here option to search by, certificate, cookie. You can use some CVE search. So I know, for example, that campaign which was introduced on the market not long time ago. So it was related to the file transfer application, which was called MoveIt. And after that, you can search for specific, let's say, reports provided by a Microsoft analyst. So I know, for example, that there is a specific group associated with this, let's say, MoveIt application. So we have here description like CLO, ransomware gang exploit, which use some vulnerability to gain access to the database. So if you open this article, you will see all, let's say, public indicators of the domains which are associated with this specific campaign. You can also track some, Defender TI indicators, which may appear here. And if you would like to see or search for the specific, exploits which are available on the market, it's also the really perfect tool, because if you know what is the CVE number, I know this one, so let me just try to type it. So you can see here that we are able to search for the specific CVE across the whole organization, and I can see if this one impacted any device which is installed with the EDR. Of course, I could check if there is any vulnerability which is well known related to this, CVE. So if you would like to have the full knowledge from the Sentinel perspective, what kind of tactics, what kind of tools, what kind of indicator of compromise are associated with the specific campaign? Because we can search for the crack map exec here, which was used by Paula. So you will see immediately that we have some ransomware groups which are trying to understand where we have SMB, let's say, shares. And after that, they are trying to look for SMB1, or SMB2 exploits. And finally, you can expect that, if you have this knowledge, you can just execute the next step. So just to summarize the part related to the Sentinel, first story is you should know what is possible inside the hunting and KQL itself, and build right detection rules. So my recommendation is to analyze what is already available by the box. Like if you add connectors, for example, to Active Directory or Azure Active Directory, you can verify all the rules which are created, and after that, try to tune it. Because it's like the first step. And please remember that by design, Sentinel is an empty box. So it's your decision how you would like to tune it, what kind of detection rules you would like to add as a custom one. And I believe that's the summary of my very quick, let's say, introduction to the Sentinel integration with MDTI. So if you already have this product, please remember that we have already integration inside the analyst rule. Analytic rules with the threat intelligence. So if you have the right licensing level, you can see, for example, this category or a rule like TI, so threat intelligence map, all the emails, which are related to the, Azure activity, or you have some IP addresses which are already detected by Microsoft threat hunters. And if we observed any activity to Office, we should just immediately create the incident. So thanks a lot. If you need, more content, more knowledge around the Sentinel, how to integrate Sentinel with MDTI, how to build the hunting queries, we have this kind of courses. So I will now pass voice to Paula.
Fantastic. Thank you so much, Peter. As always, amazing. So yeah, let me sum up a couple of things and of course announce the winner of our challenge. So that's exciting. In the meantime, in the background with the team, we've been analyzing your answers to make sure that we are fair, of course, to everybody and so on. And we've got a winner, and we actually got a runner-up as well. So that's really good. But of course, let me do a couple of summaries first. So yeah. Hopefully, of course, you like what you saw. And it's always a question, what can you do to level up in cybersecurity field, to master what you've seen already, to boost your knowledge and to boost your skills. And here's, of course, a couple of things you can do. There are different websites, books. Yeah, you can, at the end, of course, build yourself like a lab where you can test all the new tools and exploit vulnerabilities, test solutions, test your environment, and so on. Yeah, follow different resources. But of course, there's also some good, cool online communities to join. And there's, as always, as we say, slightly easier, well, maybe not really easier, but definitely more organized and more time efficient way to get more advanced knowledge and what we've just seen and what we just presented, and even more. And a lot of you already know what I'm talking about. And I'm talking first about our advanced Windows security course. And yep, that is actually a bit of a pitch before we announce the winner, but this is really the course that you guys have to take. And the reason why I'm saying this is because this is probably the most advanced course that is out there in the market. Plus, I would love to attend by myself, and I will, because I'm not delivering every single session, so that will be also my pleasure. But yeah, hopefully, of course, you will join us. And it happens, by the way, only once per year. We do not run it many times, just once per year. And we have actually prepared a special discount for you, as we always do, for everybody who participates our webinar. The full tuition for the program, it's $31.99, but we decided to give you a special discount just for the webinar attendees and everyone who will actually apply to take part in this course before October 19th. So you've got 7 days just to register. So you don't have to pay yet, but it's enough to register so that you can lock your price. So before October 19th, and you'll get approved and you will log basically the price of the $19.49 instead of $31.99. So it's a pretty huge discount. And to receive the discount, apply with the code MASTER. So you see it on the left side, and Kate, you can also put it on the chat. Maybe that will be better. And mind, of course, that application doesn't mean that you are purchasing, not yet, and that's the case. So you just register for the course. Now, advanced course, and we call it advanced just like this because it is advanced, and probably, of course, you would like to know what the discount is for. And let me introduce just a little bit of details about Advanced Windows Security Course 2024, happening just once a year. And all the details you're going to get under the link that Kate is posting on the chat. And some key facts, of course, about this certification program. It's it's already, by the way, the 8th edition of the program. 8th edition. So it has been very very good for us, and everybody is really satisfied because you learn a lot. And the program lasts 6 weeks and it starts on October 24th. So sessions are twice a week, mostly Tuesday and Thursday, and they start like this webinar, same time. So that's basically 7 p.m. Central Eastern European time, 1 p.m. Eastern. And in December, it finishes with the exam, and the sessions will be online and live with Sami Laiho, with Michael Grafnetter, with myself. Peter is going to do loads of classes. And there's going to be Mike also delivering classes. So yeah, it's a lot of us doing what we can do best. So whatever we can do best, we're delivering over there. And it's not easy. Yeah, so that's the point. And every year we create a new content for you. So there are some people that have attended every single year, and they were learning every single year. So basically, there will be tons of demonstrations, practical stuff, some really hardcore homework, so that you can get very busy in between the sessions too. Sessions last 2 hours, and they have a preparation and a homework. You will also be a part of the secret group on Discord, where we can network, chat during the time of the course. Plus, of course, you will get slides, recordings, every single live session. So if you don't feel like this is your time zone, then you can always watch the recording later and be all the time participating in the Discord group, where all of us delivering the training will be also participating, and of course everybody else. And all the, of course, precious tools that we got, precious scripts that we write on purpose for purpose of this course as well. Now, what's cool is that if you guys pass the exam at the end, you'll get from us CQURE Academy certificate. That's the Windows Security Master for 2020 year, which is also for 2024 year, which is also good to demonstrate that you are investing into cybersecurity education. And as you already know, it's not much, because for you attending this webinar is just $19.49, and there's 12 main modules, but we've got also very, very special module that is also delivered by Andy Wendell, who is actually who invested in his career in cybersecurity, and he's amazing, and he is also delivering the guest module. So he has been participating in a course, learning, and so on, and now he has become a very prominent consultant, respected consultant in cybersecurity. So he's going to be also sharing with you some interesting aspects on Active Directory security as well. So that is going to be everything from the experience, lots of stuff. Jan Marek also being on the chat here, so saying hi at the very beginning, is delivering also very cool module. There's also Ronald in terms of Kubernetes and development, Damien from our team, and so on. So yeah, lots of amazing people, I would say, just presenting their best and presenting that from the advanced perspective. So bring your advanced questions, because we will answer them, and that's the point. That's why we do it, by the way, only once per year, because it's pretty busy for us to make sure that we present new and advanced content every single year. So that's Advanced Windows Security course. You've got a link over there. It's secureacademy.com/advanced2024. And the application simply looks that as in a pretty straightforward way. So we are not technically taking everyone on board because we got a limited amount of seats. So please register, lock your seat, and then you can of course pay for that later. But it's because of course we need advanced people. Yeah, so please apply. Yeah, show us that you are advanced, because we really need to have a good crowd that's going to be helping themselves. And actually, lots of people not only find jobs in between different companies with that, but also you become friends, and we see that that community is managing very well because yeah, you grow up together in cybersecurity, and you answer sometimes your own questions. And of course, we've got success stories, as it's supposed to be. And advanced Windows security course is of course something that we are absolutely proud of, I can tell you that. And we are able to create not only international community of experienced geeks who actually for 6 weeks chat together, develop together, and so on. But we are also very proud of the different positive comments about the course, the growth, and these are, of course, also our last year's alumni. And this testimonials, they speak for themselves. You can also reach out to these guys and check. But of course, now before we reveal the winner of the challenge, please make sure that you're going to post your questions as well in the chat. Yeah, so just for the reference. And please as well, do not forget the discount code that we got for you. Yeah, that's from 3199 to 1949, and that's the code MASTER. It's only for you, by the way. Yeah, for everybody who is actually willing to learn, like you today on this webinar. So hopefully, yeah, we first of all managed to convince you, and hopefully you also will learn something, as always we try to do on our webinars. This, by the way, we promised ourselves it's going to be shorter than 2 hours, and it's just literally 2 hours. So we almost made it. Almost. And well, if you guys have questions, go ahead. We are there observing the chat right now. Thank you so much, by the way, for staying so late, especially when you got middle of the night right now. And yeah, stay secure. And thank you so much, of course, for attending our webinar. And as always, looking forward to see you around, maybe on the Advanced Windows Security course.